In this video module, we'll look at a data structure example that I call the SKU List data structure example. And so let's see here, as sort of an overview of what we're going to do, we're interested in this data set of SKUs, which is a stock keeping unit. Uniquely identifies a product, typically in some type of warehousing or distribution environment is at least where most of our interest is. And we have a very, very simple data set where we have, for each SKU, we have a cost. So this is the cost, the value of the item, the location, and you can think of the location as either a location on a store shelf or a location in a warehouse or in a picking zone or something that identifies where these units are stored. And then we have a quantity on hand. And so you can see we have 1, 2, 3, 4, 5, 6, 7, 8 items or 8 SKUs in our data set. Nominally, we would have, hundreds or hundreds of thousands or even millions of SKUs if we were looking at a large warehouse application. We want to look at something a little bit more manageable. So what we're going to do in the video module is I have a Jupyter notebook set up that has several different options for storing this data, and we're going to discuss those options. And then we're going to talk about the general process that we use when you have a situation like this where we're trying to develop and implement a data structure to store a given data set. So there are 5 steps here that we're interested in. First of all is understanding the data. There's no way to set up a data structure, an appropriate data structure anyway, without understanding what the data is telling you. Then you're going to do something that I call conceptualize a data structure. So you're just kind of thinking about the alternatives in your head, not sitting at your computer, but in your head thinking about what the alternatives are. Then the think step, where you are looking at your conceptual model and saying, will this work for what I want to do? And so that's the process where you think about your objectives, and then you consider the structure that you've conceptualized and made a decision of when it'll work. So this is sometimes an iterative process between 2 and 3. And then finally we'll implement the data structure and do some testing. So for our example, we have 3 options. There are 3 examples that we're going to look at. We're going to look at storing the data as a list of lists, storing the data as a list of dictionaries, and finally storing the data as a dictionary of lists. And finally, and I don't have it in the overview, but we'll discuss another couple of options, and then we'll end on a small assignment for you. So let's start by looking at our Jupyter notebook that you can either get from the GitHub that I have set up for the course, or I've also included the notebook file in with the video module, so you can download that and then open that in Jupyter. So here we have it. Let me shift to full screen here, get rid of some of the menus. And so you can see I have a description of the data structure example. And so on a Jupyter node, if we look at this if we look at this cell, you can see that this is a markdown cell, and you can see how we formatted the table using the markdown language. And so when you use this particular syntax and then process the cell using Shift Enter, you can see that it renders the table in this nice user-friendly format. So here's what we're going to do. We're going to look at these different options, and I'm just going to go through and discuss these because I've already written all of the options down so that we don't have to type those in. And so here's option A, or option 0 as I have it. INV0 is a list of lists. And so you can see INV0, I have this list definition on the outside here, and then each element is in fact a list within our INV0. So if I Shift Enter to process that, and then I want to see all the items in the data set, there we go. We can see the items in the data set just using the iterator. So in this case, I'm using the for loop saying for R in INV0, simply print R. And so this for loop uses the built-in iterator associated with a list. And so each time through the loop, R takes on the value of the next list. And so the very first time through the loop, it takes on this value, prints it, then this value, prints it, then this value, prints it, and so on. So all this does is just illustrates what the data structure looks like. So the simple list of lists is really simple to create. and then we can see all of that. But what we really want to create this type of data structure for is so that we can do some processing. So the first thing that we're going to do in our example is we're going to extract a list of all the SKUs in the data set. And what I'm going to do is use a list comprehension. And you can see my list comprehension here. I'm creating a new list, and then I'm saying R0 for R and I and V0. So again, I'm using the same iterator here for R in inventory. So that's essentially going to, inside the comprehension, give me each row one at a time, and then from that I'm going to extract the 0th element, or the first element, since we're using zero-based indices. And so what gets extracted is essentially, if we think of this as a matrix or a square data set, we're going to extract column 1 and we're going to create a new list. So we just do Shift Enter, and then there's our new list of just the SKU IDs. Now, what I did was I just extracted an anonymous list so that it would display. If I wanted to store this, I could just do something like SKU List equals, and then run it, and then I could store that value for further processing. So in general, this is probably what I'd want to do, is because I'm going to use this information, or I would generally use this information a little bit later on in processing. Secondly, we're going to look at, suppose that I want to get the total inventory value. So in other words, I have a set of SKUs, each one has a quantity and a price, and what I want to do is I want to get how much is my inventory worth. So obviously for each SKU I need to multiply the cost times the quantity on hand, and then I need to sum that. And so what I'm going to do is use a list comprehension and then use the sum function on the resulting list. And so again, I just iterate through my list. This time, instead of extracting an individual element like we did in the SKU list, I'm going to extract the first element, which is the price, the third element, which is the quantity on hand, and simply multiply those together. And so what I end up with is the value 771634. And so you can see that what happened was I created this internal list and then use the sum function on that list to get a single value. If for whatever reason I wanted a list of the value for each item, I could simply remove the sum function, and then this resulting list would be the list of inventory values by SKU in the same sequence that our SKU list exists. Okay, next, suppose I want to have on-hand inventory for a particular SKU. So for example, I want to have the on-hand inventory for SKU B1638. If I look at my data here, B1638 is right here, right here, and so it has a value of 2. And so in my list of lists, what I want to get is inventory 0, 1, 2, right? So inventory 2 and then 0, 1, 2, 3, right? So ultimately I want to end up with inventory 2, 3. But I don't want to use those literals. I mean, I could use those literals if I went, say, let me just go to this empty cell and say inventory 0, 2, 3, right? And there's my 2, right? So I've adequately captured that, but that's not really what I want to do. What I want to do is I want to be able to get that information, think about for any SKU value. So what I'm going to do is I'm going to use a comprehension and a index function to search the resulting list, just to demonstrate this capability. So for example, in the internal, so here's the function. So let me just process that, and you can see that I get the 2 value here. And let's talk about what's going on here. And the way to look at a complex comprehension that uses chained function is, as I've said before, is inside out and left to right. So I'm going to go to the innermost component, which is this comprehension that we've seen before. R0 for R and I and V0 is simply the SKU list that we did on top. So right here, the resulting comprehension is going to return this list, and that is what we apply the index function to. So we're going to apply the index function for B1638 on this list, and it's going to return the value 0, 1, 2. And then we have that 2 value for the first index in our list of lists, and then we apply the SKU. We know that the SKU, the quantity on hand, is stored in column 3. So one way that we would do that we might do this is we would use a variable here and say SKU is equal to let's do a different one this time, B2230, for example. And then instead of using the index on literal, I'm going to use the index on, oops, SKU. And then I look, and now we have 65 of that particular item. So there's my 65 right here. We could also do something like if we wanted to see all the inventories, we could do for, let's see, SKU in, what did I call it, SKU list. And then I'm just going to print the resulting INV0. So let's just add a print statement here. Let's print the SKU and then followed by the inventory. So this time what I'm doing is, instead of defining one, I don't need that anymore. I'm just going to iterate for each SKU in my SKU list. Here's my SKU list that I'd already defined above, right here. I'm going to print the SKU value, and then I'm going to find the index and print that. Or, I'm sorry, find the inventory value and print that. So if we do Shift Enter here, you can see that what we've done is we've extracted all of the inventory values for all of the SKUs using this combination of a comprehension and a search on the resulting list. So that's one option, and there's much more processing that you would normally do with a data set like this, but for this example, that's all I'm going to do for the list of lists. Next, we're going to move to our second option for storing the data, which is a list of dictionaries. So my list of dictionaries, you can note here I have my outer list here, which is my bracketed, so that's a list. But each element of the list is now a dictionary. So rather than having my internal elements being lists, this time their internal elements are dictionaries, where the keys correspond to each of the column identifiers in our table. So we have SKU, the key and the value, cost, the key and the value, location, the key and the value, and quantity, the key and the value. So as with the list of lists, creating the list of dictionaries is pretty straightforward. So I'm going to Shift Enter. And then if we want to show the items in the data set, of course we use basically the same loop that we had before for R and INV1, because INV1 is a simple list also. It's just that the resulting elements are now dictionaries. And so if I compare the two, this loop with INV0 with my loop with INV1 with my loop with INV0, the resulting elements are lists, and for INV1, the resulting elements are dictionaries. So on to our next thing. We're going to do the same basic processing that we did in example INV0. So the next thing I did was I created a list of all the SKUs in the data set. So Shift Enter, and so I'm using a list comprehension. And note, I'm using the key value rather than the index of the list. So for our list of lists, I used R0 because I knew that the 0th element in each list was the SKU ID. And for our list of dictionaries, I'm using the key value SKU to identify the individual, or try to extract those SKU values. And so one note here that you can see immediately the difference is that if I use the list of lists, I need to know the index value. I need to know that it was stored in index 0. Whereas if I used a list of dictionaries in this case, I need to know that key. I need to know this key value is SKU. And sort of if you think about this as a matrix, it doesn't matter what the actual physical column is, I just know that key value. Secondly, if I want to get the total inventory values, it's a very similar thing before. I'm using the same kind of comprehension, but again, in this case, instead of using fixed column values that we did for the list, I'm using the key values. So there is the total inventory value. And again, the last thing I want to do here is if I want to get the on-hand inventory for the particular SKU, B1638, it's very similar to what we saw before, except I'm using the SKU key value here and the quantity key value here. So whereas before here, well, I guess I got rid of that on-hand inventory, but here it is. I had the SKU value here and then the column level here, column value here, whereas in this one I'm actually using the SKU key, the SKU key value to identify the SKU, and then oh, there we go, 2. Got down to the next one here. Right, so I'm defining SKU here, B1638, and then I'm finding the index here just like we did before. And then using the SKU key, I'm creating the ultimate list. So you can compare these two between using the list of lists and the list of dictionaries. They're very similar. The primary difference is whether I use a column index or I use the list index, I should say, because it's not always a column. Whether I use the list index or whether I use the key value is the primary difference between using a list of lists and a list of dictionaries. So our final example that we're going to do in this video module is a dictionary of lists. So in our previous two examples, the outermost part of our data structure was a list. So INV0 was a list of lists, INV1 was a list of dictionary. This time we're flipping things around and we're creating a dictionary where each value of the dictionary is a list, and the key is the SKU ID. So we have a SKU ID is the key, and the list is the price, the location, the quantity on hand. And so to create our dictionary of lists, we simply have this outer dictionary structure, and then for each different element, each component of the dictionary, I have the SKU being the key value, the key, and the list being the value. So this time, if I want to show all items in the data set, I'm going to iterate, and note that when I iterate through a dictionary, so for K and I and V, the built-in iterator returns the key value, the list of key or the corresponding key values. So the first time through the loop, K is going to equal A1004. The second time through the loop, it's A1012, and so on. So in my print statement, what do I have here? INV2, what did I do? Show all items in the data set. I forgot to run this one, so there we go. Go back and run it. Okay, sorry about that. And so you can see that when we use the print statement, now we have to print both things. I have to print the key value and then the actual value from the dictionary. So recall that I have the key, INV2, the brackets gives me the resulting list. So I want to see also all the SKUs in the data set. I can just use the keys function. The keys function returns all keys in the dictionary, and so that's a way to create my list. Also note that I used the list function to create the list. If I don't do that, there's a built-in type in Python, so let's remove the list identifier there, and there we have a list of dictionary keys. So if I want the dictionary keys as an iterator or similar, I can do that. If I want the list, which is what we did in the previous two examples, I can simply use the list function to generate that. Okay, so total inventory value, again, exactly what we did before. I'm going to do a sum. In this case, I'm doing K and INV2. And recall what this iteration does for K and INV2 is return the key value. And so the summation values that I'm doing is INV2 key 0. So this INV2K is going to return to me one of these lists, and then I need the 0th element and the second element to multiply those together to get the inventory. So there's our same 7634. And then the final thing that we do is get on-hand inventory for SKU B1638. And so you can see it's a very simple thing here because I just put the key value, the SKU for the key value, and then I know it's element 2 of the resulting list. And so in this case, getting the on-hand inventory was a bit of a simpler operation in previous because I didn't have to search to find the row index. In our previous two examples, when I wanted that, I had to do a search process to find the row because I was storing everything as a list. In this example, since I have everything stored in a dictionary, as soon as I know what this key value is, the SKU, I can just immediately jump to that element of our dictionary and then extract out the meaningful information, in this case, the on-hand inventory value. So we presented three different options. Let me scroll back up. And we then used each one of those options to generate the same basic set of information. The first one, INV0, is a list of lists. The second, INV1, is a list of dictionaries. And the third, INV2, is a dictionary of lists. And we looked at the relative ease of extracting information. And so each one has its relative benefits. One thing that I mentioned here is that getting the on-hand inventory in this case was simple because we just had this key value. And so I also mentioned in the very beginning of the video module I was going to end with an assignment to you. And so the assignment is, suppose I want to have where I don't need to know the row value, or I don't need to know, the element ID for anything. So suppose I wanted to do something like INV3 B1638 and I want quantity, right? And so in this case, instead of knowing that it's the second element of the list, which I have here, I just want to put in what I want. I want to put in the piece of information that I want, QTY. And so to do this, what do we need to do? Well, hopefully you said we need a different data structure. I need a dictionary of dictionaries, so that the very first component here extracts the value, and in this case the value from the dictionary, but what gets extracted, instead of being a list that I can then jump to the second element, is a dictionary that I can use the key value. And so in this case I don't need to know which element it is, I just need to know those two key values. And so this is the task that I'm going to leave for you to try on your own, and be sure and give that a try. So back to our overview, the process that we went through is understand, let me make this all, that's not what I want. I want to go back up and do that. Understand the data, conceptualize the data structure, think, implement the data structure, and test. And these two tasks, conceptualize the data structure and think, require a bit of experience and a bit of understanding of the different options for doing Python data structures. So in general, for beginners in particular, their first thought is to do a list of lists because it's a very simple data structure. It's a simple data structure to implement. It's a simple data structure to understand, especially if your mind tends to think in terms of matrices, which in engineering our minds typically do. So that's a very simple data structure. Secondly, when people new to Python are introduced to the concept of a dictionary, they immediately see the value of being able to just use that key value. So instead of knowing what column things are in, you just use that key value. So people immediately try to jump to that. How can I do this as a dictionary? Over time, what you learn is you learn to evaluate the options and saying, let me look at the task that I have at hand. And then that's this loop, or this iteration between conceptualizing the data structure and thinking, so that what you end up with is the best data structure for the task at hand.